This is for lesson 3, solving a system of equations by substitution. Alright, so we have a system of equation, 2x plus 6y equals 22. Now that's our first equation, and we have our second equation, 5x minus 2y equals 4. That's our second equation. Now, it's kind of important at this stage in the game that we keep the two equations labeled so we know what we're doing. More on that in a second. Now, unlike my other videos, I actually have 4 steps that I want you to follow, and I got them written out here, so make sure you use this method for solving a system of equations by substitution method. We're going to isolate, substitute, solve, and backsolve. So, step 1, isolate. We're going to solve for one of the variables from one of the equations. So once we know what either x or y is, we're then going to plug this into the other equation or substitute that in. Then, step 3, we're going to solve this for the only variable remaining. And lastly, I'm going to take that value and backsolve. In other words, plug this value into any of the other equations and solve for the remaining variable. So, first thing you're going to do is you're going to pick one of the equations to get by itself. Now, in my first equation, the 2x that I see right here looks like I can get by itself fairly easily. I'm going to have to move the 6y to the other side and divide everything by 2. Let's go ahead and do that. So my first equation, 2x plus 6y equals 22. And I'm aiming to get this x from my first equation by itself. So I'm going to do that by subtracting 6y from both equations, yielding 2x equals negative 6y plus 22. I'm now going to divide everything by 2 and get x is equal to negative 3y plus 11. So now I've isolated the x from the first equation. My next step, substitute, I'm going to plug this into the other equation. So my other equation was 5x minus 2y is equal to 4. I know what x is equal to. X is equal to negative 3y plus 11. So now I take my 5 times x minus 2y is equal to 4. But instead of writing x, I'm writing down negative 3y plus 11. Okay, and that's it for step 2. I've now substituted. Step 3, I'm now going to solve this for y, since y is the only remaining variable I have. So I'm going to distribute the 5 through to get negative 15y plus 55 minus 2y equals 4. I'm going to combine my like terms of 15y and negative 2y to get negative 17y, and at the same time, and then plus 55 equals 4. I'm now going to go ahead and move the 55 to the other side by subtracting it, and I get negative 17y is equal to negative 51. In other words, divide both sides by negative 17, and I get y is equal to 3. Alright, and that's it for step 3. I got the variable all by itself. Y is equal to 3. Now I'm going to plug this back into any of the equations. Now I could plug into equation 1 or equation 2, but what I like best is we already have the x isolated. So x is equal to negative 3y plus 11. That was a rewrite of my first equation. And I'm going to plug in for y 3. So I get x equals negative 3 times 3 plus 11. In other words, x equals negative 9 plus 11. X is equal to 2. Now, I never write this down as a step, but it's kind of implied. The solution to a system of equations in this case is a point, and that point is 2, 3. Right? Alright, that's it for substitution.